respected dignitaries, esteemed guests, faculty members, dear students, ladies and gentlemen. It is indeed an honor and privilege to welcome you to the third day of celebrating AICTE training and learning faculty development program on the theme of next gen AI techniques for biomedical data interpretation, organized by the Department of Computer Applications, MCA and BCA, Gandhi Institute of Excellent Technocrats, Ghangapatna, Bhubaneswar. We are delighted to honor Mr. Uday, a senior specialist from GIET, as an experienced solution architect with over 15 years in the industry. Mr. Kerr brings a unique blend of expertise in visualization and cloud platform. His talk on preparation techniques for biomedical data is fundamental, as proper data preparation is the first and most critical step in any successful AI project. Now I request the lead sir and convener Swarupa ma'am to give the flower bouquet to our esteemed dignitary. Now I request Mr. Uday to start their session.
My good wishes and to all the delegates, students representative, our HOD madam, respected faculties, our guest resource person of the third session. So I wish all the success and grand success of that faculty development program. Thank you all.
Tech stack that normally industry is working on, and I want this discussion to be pretty much interactive. Whatever doubts, whatever thoughts you guys will get, feel free to ask. And in between, I'll take pause and I'll try to brief about what exactly we are going to talk about and how you can start utilizing similar kind of process in your day-to-day activities, whether at the time of practicing for job interviews or exploring some kind of new technology that I'm going to talk about, or maybe like if you're working on any kind of project and you want to utilize some kind of latest tech stack in it. Okay. So the topic that I'm going to talk about is pretty straightforward. It's how you are going to process different kind of data in the biomedical domain, right? And when we are going to talk about data, so generally data will always differ depending on the kind of requirement, because medical domain is a vast domain, right? And we used to get varieties of data, right? So before getting more into this discussion, let's take a quick look into the content, what all things we will cover. So the whole discussion is basically split into two different parts. One, what kind of data we are going to talk about, and second one, how we will process those data. Okay. So generally, think about a small hospital where different kind of biomedical data are getting generated, right? So what kind of data normally you can see? Let's say one doctor is just sitting there as a medicine specialist, and lot of patients are coming for different kind of diseases like fever, flu, whatever it is, right? So when they are preparing the prescription for individual patients, normally few common things they need to take as a note, right? Like patient's name, age, sex, then since how long the disease is happening, then what are the symptoms, right? So here, certain component of those checklists which are very niche to every individual person, and when you will go for processing those kind of data, normally you should not share those information with anybody, right? That's the reason, like there are a lot of regulatory acts are available based on which whoever is the organization going to interpret those data or process those data, they have to make sure certain user identity or patient's identity are completely disclosed. Okay, they can't. Completely hidden. They can't disclose those informations openly to anyone. Okay, so we'll talk about like what are the different kind of data we are going to use, how we can sanitize those data, and once, let's say your initial data sanitization is done, means you just took the patient information and fine-tune those data, you remove the patient-specific details out of it, like name, age, all those parameters. It becomes a very generic data, right? Now, how you will pass those data? So normally, like, how many of you are not using smartphone these days? Nobody, right? Everyone is having a smartphone. And normally what do? We go to Twitter, we go to LinkedIn, we go to Facebook, and whatever like open source or you can say the social media is available, everywhere we perform some kind of activity. Either we click photos, we send text, we receive text, right? So if you look, every activity is associated with some kind of metadata, right? So metadata means data, information about some data, right? So if you look into a particular image, the image itself has some information like where that image got clicked, what is the size of that image, like what is the dimension of that image, all those stuff, right? So those kind of informations normally we should not keep open when it comes to a certain environment, whether it's related to biomedical or it's related to fintech, whatever it is, right? And once those data will be sanitized, assume like from an individual person, if the quantity of data is so large, when we will talk about the complete hospital, where every day thousands of patients are coming, and if we talk about the data for a period of 6 months to 1 year, how much data actually we are going to talk about, right? The data size is going to be very large. Now, how to manage such large data in any organization, that itself is a big challenge. Okay, so I will talk about a couple of options using which data are actually managed in different organizations. Then we will look into the process based on which we can fine-tune those data in a automated way. Okay, so this CIET, second part is this CIET principle, which will basically consume those unsanitized data, and why process automatically it will sanitize. Because let's say I will give you a patient details where it's going to have few information, and I'll ask clear those informations. You can do that manually. But if I will give you like 10,000 or 20,000 patients details and I'll ask you go and finish those data sanitization in couple of hours, definitely it's going to be a big challenge for anybody because manually cleaning up anything is going to be very difficult, right? So we will follow certain process using which we can do those cleanup activities. So first, let's try to understand what kind of automation flow we are going to talk about here. That normally we will follow, in our practice approach. Before coming to this, just want to understand, like, you guys belongs to which year right now? MCA second year. Okay. Have you heard about a word called cloud technology? So, like, what kind of cloud technology you guys are aware of?
Cloud, there is some tactile store.
Okay. No, I'm not asking about what is cloud technology. I'm just asking, like, what kind of cloud technology names you guys are familiar with, like Google Cloud, like AWS, Microsoft Azure, DigitalOcean, Oracle Cloud, right? There are a lot of cloud vendors. Okay. Second part is, have you guys heard about another word called DevOps? Yes, sir. Okay. How many of you are familiar with DevOps? Okay. Have you guys finished any kind of programming language so far?
Yes, sir.
What are the programming language you have finished? You finished quite a lot. C, Python, Java, then C++. All right. Then normally, like, have you ever tried to create a program which will just add, let's say, 2 numbers in any language? You have done it, right? Now, have you tried to create a program which will perform the same task, but you will not feed the data, you will just run the program and someone else will come and try to feed data? Does that? Okay. Now, assume the same task has to be done by 1,000 people at a time, right? So whatever activity you are trying to do with 1 or 2 persons, that's pretty simple, right? You don't require a lot of logic because you just provide a printf with some basic logic to add 2 numbers, then you are just displaying it, right? But when you want the same program to run by 1,000 people, you need a lot of additional stuff. Like you need a good interface at least so that people can look into those data and feed into it. You need system where you can run the program constantly and individual people can browse it from their system or from their laptop or from their mobile, right? So when any kind of activity we want to do beyond 2-3 persons, we need to give a detailed script to it, right? How those programs can be used by different people. Think about like Facebook chat, right? Facebook has created a single program to chat easily between a couple of people. Now let's say in one end you are sitting, in another end your friend is sitting. So you guys are interacting with each other, but the whole communication is happening via a server, right? Which is sitting inside Facebook's data center somewhere in the globe. Similarly, when you need to process a lot of data, you need to create some kind of backend system which will process this data in a meaningful way. And when we are talking about those backend systems, it's just not a single component. It requires a lot of components with it, right? Because normally when you are studying operating system, you are studying programming languages, you are also studying databases, right? But normally when you create an application, it's basically a combination of all these three. Right? You need an operating system where you will install a database and where you will run your programs, and finally your program is going to talk to your database and going to perform some kind of activity. Right? Then obviously if you want your program to have a user interface, you can create a front end for it. Right? So these are the 4 different pieces that you will combine together to perform some kind of activity. Right? So here also, to perform activity at a different level, we have different tools. Okay? Have you, those guys who are familiar with DevOps, have you guys heard about a tool called Jenkins? No? Not yet? Okay. Anybody heard about a tool called Docker Container? No? Okay. So if these tools are not familiar, then I think you guys need little bit time to understand these tools at first. Because once you will pass out and you will try to go to market as a developer or as a system engineer or as a solution architect or as a cloud engineer, you need these tool set for sure. Without these tool sets, it's not possible to go and start working easily. Right? So we'll talk about those tools and their approach a little bit. We can't cover all this in detail, but I'll try to give you some idea how these things are happening together. So as a part of this pipeline process for fine-tuning biomedical data, we'll talk about the source of data from where we are collecting those data. Then the sanitization means the data that we are collecting is having a lot of core information about patients. How we can sanitize those data. Okay. Then we will talk about what are the data sanitization standard. Okay. And then once your sanitized data is ready, what additional activity can be done with the help of Jenkins, containers, and some platform related tools like Docker and Kubernetes. You will see that. So let's take a look like how a normal patient data is going to look like, and if you want to sanitize that data, how it's going to look like. Okay. That's good. So ignore that Python program. So that's just a small program which is basically going to read your data and going to fine tune it. So I hope this section will be clear to all, right? The patient information. So basically this is going to have very basic information like the patient's name, date of birth, the MRN number, the phone number, when the patient is actually visited, the disease diagnosis type, and the prescription. Okay. So whatever medicines has been recommended to that particular person. Now in the similar way, when let's say you have multiple data, I just took two different patients example here. Okay. These data will be fed to a particular Python program. You can have any program. I just do the Python one because it's very easy to use and parse data. Because in the world of data analytics, if you would like to go, Python is the tool for you. Now once these patients data will be fed to your Python tool, what Python will do, it will identify, depending on what kind of logic you have written, it will try to identify what are the core informations you have in these sentences. Okay? And it will try to filter them out, and finally it will give you the sanitized data. So if you look the original data versus the sanitized data, what is the core difference between these two? What you can see? What are the core difference you can see between the general data versus the sanitized data? Right. So in case of sanitized, we are removing those values. We are not keeping values. We are just making the data as a generic one, because patient's name is not a big deal. The disease can happen to anybody. So the important factor we need to figure out what is the disease, and based on the disease, what is the prescription that has been recommended to the patient, right? And if the disease is happening repetitively, let's say in a particular day, one doctor visited 10 different patients, okay? And out of the 10 different patients, they found one particular disease is happening at least with 3 or 4 people, okay? And the behavior is exact same, and they are prescribing a particular medicine for all 3 or 4 people. Now, what you will assume out of this? Either the disease is very common among people, or it's a seasonal disease because on a particular time it's happening to almost everybody. And if that is happening to everybody, then almost everybody needs the same medicine. manufacturer of the medicines, so that they can understand, okay, if this is the duration of the year, then these kind of diseases are common. And if certain diseases are common, then we have to make sure we are always ready with additional medicines with us. Otherwise, we can't provide right medicines to people and people will die. Right? So, this is just a small example how medicines manufacturer use this kind of information from different medical organizations and work with medical organizations to make sure the right medicines are always available on certain specific time. Okay? So here, if you look into this data structure, okay, this is just a data, right? It's pretty well organized, because if you look both the data, you can read them easily, you can understand them easily. And if you observe both the data, the pattern is same, right? So this is the kind of data we call as structured data, where your whole data is available in a particular format, right? So, analyzing this kind of data are very easy. You just need to put a for loop. Every patients are going to have the same, keyword. Whatever thing you will see in the left side is known as key. Whatever thing you will see in the right side is known as value. So value will just change, key is same. So you can easily interpret this kind of data. But challenge is when you will look into the unstructured data. So unstructured data means it will come randomly in a particular sentence. Multiple things will be available, and out of that, it's a bit difficult to parse those informations properly, right? And when you will get such data for multiple patients, definitely it's a big challenge. So when you develop your program, you have to make sure it's going through each entry line by line, and it's able to understand and it's able to interpret those informations correctly, and then it can create the generic output of it. Okay? So this is another way of generating data. Now question is, if we talk about the medical science, from what all areas you can expect to get some data? Let's talk about the machines type, right? So if you go to the X-ray machines will generate some kind of data. If you go to the MRI machines, they are also going to generate some kind of data. If you go to some scanning machines, they are also going to generate some kind of data, right? So here, data are getting generated in multiple ways. The doctor, when they are preparing the prescriptions, they are generating data. Those might be manual. In certain hospitals, when you will go, first they will create a profile for you, okay? And based on your visit, they will make sure whatever number of entries they are going to have. If you have any previous medical record, they will try to capture everything. And in the system itself, they will start dumping all those data to make sure your data they are going to keep at least for 6 to 7 years to understand as a patient if you are coming repeatedly, right? What kind of behavior you are coming with, what kind of diseases you are coming with, and how frequently those diseases are getting repeated. Then out of that, they'll try to figure out a meaning, like is it a pattern of having something based on season, based on family background, based on the age, based on the sex, based on the environment. Okay, so based on certain conditions, they'll try to understand if this kind of diseases are happening frequently, right? Then that's basically going to give you some. That's basically going to give some idea to doctors or to researchers to understand the pattern of that particular disease. Okay. Now let's say once your whole data is going to figured out or synthesized, how you will store them. So normally, how many of you have laptops with you? Okay, how many of you have mobiles with you? Everybody, right? What is the size of your ROM? 64, 128, 128, it's close to a laptop now, right? Because you have to dump a lot of data in terms of photos, videos, WhatsApp videos, Facebook videos, or any kind of movies. So your mobile itself is getting more powerful day by day, right? But if you observe, the important part in your mobile is the amount of storage you are going to get, right? Now, assume with a small person, like if you just going to have a temporary mobile whose memory capacity is 128 GB just to store data, if you need to store data in a particular server, how much size the server is going to have? Okay. So in general, in real-time environments, when we talk about data, we normally talk data in terabyte or petabyte in size. Okay. So 1 TB is equal to 1024 gigabyte, right? And normally, if you look, your systems are either having 64 gigabyte or 128 gigabyte. But for any large organization, when you will store any kind of data, okay, the size is going to be very large. Now, assume like you have a single mobile, okay, and in your mobile you have only 164 or 128 GB of ROM. For some reason, that ROM got corrupted. What will happen? Data loss, right? Now, in corporate environment or in medical domain or in any scientific research environment, is it possible to lose data randomly? The answer is no, because there is no guarantee that in any circumstance those data can be reproducible, right? We don't know whether we can reproduce those data or not, right? So you always try to have a copy of those data. Have you guys finished reading computer architecture? You guys have computer architecture? In which semester? Second semester. So you guys have gone to CAR, right? You guys computer organization and architecture or what? Have you guys heard about a term called RAID? R-A-I-D. Redundant array of independent disk. No? It was not there. Correct. No. So, in corporate world, when you go to work for any organizations, even depending on the data criticality, normally at the server end, the servers are configured with RAID. Okay. So if we talk about RAID, there are multiple versions of multiple types of RAIDs available, right? Starting from RAID 0, RAID 1, then RAID 5, RAID 6, RAID 10, and every version of RAID is having its own benefit. So let's talk about RAID 0, okay? A very small and easy one. So any idea, like for RAID 0, how many disks do we need? For RAID 0, how many disks do we need? Okay, so at least 2 disks we need. Okay, RAID 0 works in with 2 disk format, and let's say I'll give you 2 disks, and I have a word called hello. H-E-L-L-O. Okay, so how it will be stored? In first disk, H will be there. In second disk, U will be there. In third disk, L will be there. So it will basically split between 2 disks. So here the challenge, for some reason, if you lose one hard disk, your total data is gone. Even if you have 2 hard disks, it's not going to be very helpful. Okay, that's the reason they come up with another RAID called RAID 1. So RAID 0 is splitting. RAID 1 is mirroring. What mirroring will do? It will, let's say, want to store a word called hello. So hello will be stored in your hard disk 0. The exact copy of hello will also be stored in your hard disk 1. Now let's say I lost one disk. Am I going to lose data? No. Now I will not lose data, but the way data getting split across 2 devices, I need lot of storage. Now storage is not that cheap, okay? Because if you want to get fast data, right, you need to have high-end processor, you need to have high-end data bus which can bring data transfer from your devices and then pass it to the application, right? So that's the reason to maintain the data integrity properly. They come up with another kind of RAID known as RAID 5. So RAID 5 will do what? It will store data in two different disks. So RAID 5 works with three different habits. It will store data in two disks, and the checksum of this data will be stored in another disk. Okay, so it's not the exact checksum, it's the parity. Now, based on RAID 5, it can handle one disk failure, but it can maintain the data performance very easily. It's not going to block anything for you. Okay, so this is how the data are, this is how the data are basically getting used in the corporate environment. Now, once your data will getting stored like this, eventually, if they will start growing over a period of time, you will realize you are going to have terabytes of data, and over a long duration, you are going to have petabytes of data. Do you know, like every day, how many storage servers get attached to Facebook's data center? Like recent information, I don't know, around 2015, 2016, every day they used to map around like 40-45 terabyte of storage to their existing data servers, because the amount of data they used to get from the end applications was massive, and because of such massive data, they needs to expand the storage very, very fast. Okay, so that's the reason, like it's very difficult. If you not scale your servers properly, it's very difficult to manage data. Now, as you are getting terabytes of data, and you have to process them manually. And I just show you, like, let's assume like you have 1 terabyte of data with just patient's information. So the file we saw, that file is hardly, bytes. Okay. So if you have, let's say, 1 lakh such files, the data size will be hardly in MB. So if you have, let's say, at least 1 CR files, the file size will be in GB. Okay. Now, how much time it required to run that program and pass that user data one by one to get those output? It's extremely time consuming, right? So to overcome this, what you need a pipeline. What pipeline is all about? So let's talk about some food. How many of you love chaat? Almost everybody, right? And normally, if you look into the preparation process, you need potatoes, you need butter, some spices, some little bit of ketchup, and some other masalas. Then somebody needs to mix them together, and then again you have to prepare the way so that it can look nice and you can serve it to somebody, right? So overall, if you look, normal chart preparation is going at least in 3 or 4 different stages, right? Similarly, whatever data preparation will do, it will go via multiple stages. So your first stage is going to be data sanitization. Means whatever raw data you get either from machines or from your doctor's prescription or from any devices or from any scanning devices, those data has to be sanitized first. So that sanitization process is a clean process. Now to do that sanitization, as we understood the data size is very big, we can do that manually, right? So what we will do, we have to sanitize them via certain process. Now first process is, you need a storage where you keep all those data. Now you can understand what the storage is. At least you need a terabyte storage with RAID 5 so that you are not going to lose data. So let's say you have 1 terabyte of data with you. Now once data is available there, you need a Python program which will read those data, then filter out the human information and convert it into a generalized mode, right? So normally nowadays, if you need to run a program, where are you running the program? Where? Yeah, in CPU and memory, right? That means you are running that program inside a system. right? Now let's say I want to run, you know, 10, 20, 30 different programs, right? So what I need, at least, if each system is running a program once, I need at least like 10, 15, 20 systems to run that program, right? Now challenge is, let's say you have 10 laptops. You are running the same program 10 times, I mean individually on each laptop. For some reason, on one laptop the program got corrupted for XYZ reason. You will lose that particular machine. That means your overall efficiency will be reduced by 1/10, right? Because you will lose one machine. Now, in normally in corporate world, this is the biggest challenge because you have to deal with performance, you have to deal with applications, you have to make sure your applications are giving you the right output. So last time when you booked a ticket on IRCTC, anybody booked a ticket recently on IRCTC? IRCTC is a website you guys know, right? To book train tickets. Recently no one booked, right? Okay, anyone has booked any flight tickets recently? Okay. So assume like IRCTC is a site. You will go into the site. Okay, have you ever booked any ticket on IRCTC? You guys have booked it, right? So just like you did on the same day at same time, a lot of people are also trying, right? Now have you observed this slowness, like it will keep on buffering, then it will time out. So like session timed out, right? Have you observed that kind of thing? Okay, so what exactly happened when you pass certain information, and mostly this happen after just giving the payment information, right? Because the moment you will give your payment information, it collected your information and trying to book a ticket for you, book a seat for you, and exactly at the same moment, multiple people will try to book that seat. So when your CPU will receive the first instruction from a person, it will confirm the ticket for them, right? So exactly in the similar way, when you try to process a lot of data, your applications are going to be same. It's just like how efficiently your applications are going to process those data, that's going to determine how efficient your code is, right? Now to make efficiency, it should work in two ways. Just your program can increase the efficiency. Your system where your program is running, that also should support the good amount of efficiency. Okay? To run concurrent programs and handle the resource distribution to the programs easily, right? So what will happen, if we talk about the server, so instead of giving one machine for one application, what they did, they created a virtual application or virtual machine, okay? We call that as a virtual machine. We are in the world of virtualization. We call that as a virtual machine, and within that machine they will run the application. So you might have a single server or single laptop, but if you have resources in terms of RAM, CPU and hard disk, you can create multiple VMs on top of it, and inside each VM you can run one replica of your application. Okay? And when your data pipeline of 1 terabyte will be fed, it will be fed to all the applications running inside different VMs, and they can do the independent processing. So your application processing will be run in parallel, system is not going to be extremely overloaded, and you can achieve the target output in desired time, right? Now, assume like you have a sports period, and let's assume like you are 60 students, and you all want to play football, so you all gathered around the football ground, and you all decided, okay, we all are going to play football. There is a single ball. There is a single ball, and you all decided you will play football, right? But no one is ready to follow any kind of instructions. So what will happen? You will get big chaos, right? Because you want to perform something, but you don't know when to stop, when to start, when to pass, right? Everybody is trying to hit a ball, right? But that is not how the whole game has to be scheduled, right? So in this kind of situation, it's very difficult manage multiple people, those want to perform a single task. Same thing will also happen in your system. Let's say you want to run something and in parallel you started multiple programs, your system is running out of resources, your kernel will die because you can't manage all the programs very efficiently, right? So this is the kind of situation where we need better programs. We can understand how to handle multiple applications in parallel and do the processing of certain activities. Okay. Now, if you look here, we have mentioned about one word called GCS bucket. Okay. So, have you heard about a term called Google Cloud? Have you heard about that? Okay. So, Google Cloud is a cloud provider, right? And this example I took, assuming like in your laptop you don't have enough space to store terabyte of data, so you need a large, storage pool, which is nothing but a cloud vendor where you can store enough data, right? So normally people prefer cloud vendors. Why? Because upfront paying and purchasing hardware, then integrating them, then started storing data into it, it's time consuming. So instantly if you need data, you can just go to a cloud platform, purchase the amount of storage that you need, and you can get ready hardly within 5 minutes, right? If you have a valid account. So in that case, if you need to process things faster, it's always good you can start with cloud, but once your things will start growing and you have a proper plan in place, you can plan to come back to the data center requirement. So this whole example I took by keeping in mind, like we have a lot of data and we want to keep those data somewhere in a cloud environment. Okay. So normally if you look, GCS stands for Google Cloud Storage. So assume like you don't have your laptop, you just have a big cloud environment which is called Google Cloud Storage, where you can store petabyte of data. And once from different hospitals, multiple data came in, they will be stored in the GCS in typically raw format without any kind of sanitization, right? Then you develop a Python program which can read data from your storage and can understand the kind of structure, whether it's structured or unstructured, doesn't matter. And then it can figure out, it can basically filter out and sanitize your data. Then once data sanitization is done, it should go to the next stage. There should be another way of validation which will make sure there is no PHI information remains inside the data. Like sometimes what happens when you are writing a code, when you try to execute it, sometimes it will give you some kind of error, right? But we will call that error bug, right? As we are humans, when we are developing programs, there could be bug, there could be error, right? Now, if let's say you process 1,000 users data, and by mistake for one user, some synthesization is not done correctly, you should make sure you have one additional condition or additional state to filter that out. Okay? Because if you pass this, you will get a regulatory penalty, your organization will be banned from processing those kind of data, and the result could be anything, right? Then let's say now in stage 2 and 3, data sanitization and fine tuning is completely done. What you will do? You will pass that data to the container application where your Python code is running. Okay, so the Python code basically makes sure whatever data you have received, those are completely sanitized. Okay, and whatever code you will develop, that code also has to be tested thoroughly, right? So that code has to have a Python interpreter inside a operating system. If you are going to pick a very lightweight operating system, it could be a Docker container. And once that code is compiled, it will make sure the code is ready to handle that data. Then, a lot of time what happens? Okay, how many of you guys have Windows operating system in your laptop. Any Linux? Which one? Ubuntu. Which one? I think Linux. Where you go to making or what? Okay. So in case of Linux or Windows, so normally the container images you will get in real time are pretty much Linux. So very rarely people used to have a Windows-based container image, okay? Because it's having a lot of dependencies. So irrespective of operating system, nowadays viruses are common. Or infected programs, viruses are nothing but infected programs, right? Those can damage your system or application. Now to scan them, okay? So normally in case of a laptop, you need an antivirus to scan your operating system or infected files or videos, images, right? Similarly, in case of container image, we also need a scanner which can make sure the container image that we are taking is actually fine-tuned and it's ready for the production environment. So there is a tool called Trivi. So there is a company called Acquia Software. It's a global MNC, and they have created this tool called Trivi. It's a fantastic tool to scan your container images, and it can tell you if your container image is having 5 different applications in it, which application is having a issue, whether issue inside the code or issue inside the issue in the way it's using resource. Have you heard about a term called memory leak? Huh? Sometimes have you observed when you are using your phone continuously for maybe a month or two, sometimes it responds very slow, then what do you normally do? Go ahead and reboot it, right? Definitely. Reboot is the solution. Why? Because if there is any new application which will come into your system or mobile which is not well tuned, what it will do, for every application's execution, it requires some amount of memory, right? So let's say you started WhatsApp, and assume like WhatsApp is having some kind of memory leak, and assume for WhatsApp to process one message, it requires 1 MB of memory. So you extract one message, it consumed 1 MB of memory, it took that memory and kept it. It never released that, because once the job is done, there is no point in capturing those memory with you, right? For application is not ready. But if it's holding that memory, that means it's a leak in the application, it's not releasing that resource. So let's say you have 4 GB of RAM, right? It means 4096 amount of MB. So the moment you will finish sending 4096 amount of messages, your system is out of memory. Your system will hang, the mobile will hang. Then what you will do? You press the button and reboot it, right? Exactly in the similar way, for any enterprise application, there is a possibility, like applications might have any kind of memory leak or any kind of other system performance similarity issue. To fine-tune those, you need a scanning system which will scan and make sure the tool you are going to use are really rock solid. Okay? Next part is, so let's say you prepare those images, you need to store them somewhere first, right? Because approach is, you created a container image, you have to store it somewhere, then when your application will start, your pipeline will start, it will pull that image, it will pass files to the images. Once scanning is done, image is gone, resources are free, and you will get the fine-tuned data, right? So those images will come from somewhere. So that somewhere part we call as registry. Okay? So as these are known as containers, we call them as container registry. Now once your image is ready, fine-tuned scan, it will be pushed to the registry, and then when your actual application will start, okay, those images will be deployed on top of a platform. We call them as Kubernetes platform, or if you want to run them in a small bunch, you can call them as Docker Edge platform or virtual edge platform, and then your applications will be fed. Your applications will start reading those data from the large data source, and finally they will perform the sanitization, and once sanitization is done, they will put them back to a different bucket. So normally what happens, let's say you want to perform any kind of data sanitization, you need to have 2 different storage. One storage from where it will read all the data, and once fine tuning is done, it will store them somewhere else. Okay? And once data sanitization is done, then the critical part is coming where you will use those sanitized data to generate reports. Okay? So those report generating part. So right now assume your sanitized data is available in a dedicated bucket in GCS. So bucket means a place where you can dump your data. Okay? It's available in the Google Cloud storage. Now from those sanitized data, it has to pass to some analytics engine. So analytics engine is nothing but a kind of program which will read those data and it will create some reports. Assume like in the month of August, to one hospital, 1,000 patients came. Out of 1,000 patients, when they sanitized the data, they figured out 600 patients were suffered from viral flu, okay, or viral fever, and out of those 600 patients, those were having viral fever, 400 patients were having exact similar symptoms. They were prescribed the same medicine with similar dose, and they were finally cured, right? Which is indication like when the data is sanitized, when you will push this kind of data to a analytical engine, based on the common patterns, it will figure out the reports, and those reports can be easily checked by different experts to identify what exactly happened, right? So normally, did you guys have gone through any kind of database related course here? What were databases you have finished? MySQL. Okay. So let's say you have a MySQL employee database. Have you created employee database? Created? Student database. Okay. So let's say I would like to filter out all students those have scored more than 60%. This kind of query you have written, right? Because you will start feeding multiple student information with different scores, different locations, different age group, different semester. Then you would like to filter out those kind of data, right? So analytics is more or less the similar way. So you have a common big pool where you have a lot of data, and out of those data, you want to filter out something quickly to generate the report, right? So let's say in your college you have 1,000 students. Out of 1,000 students, 750 students actually passed with 60% plus mark. You want to figure out all the usernames. So you will select start from student where a student scored more than 60%. You will get all those details. Then maybe on another one you can just filter out individual users details, right? So in the similar way, here in analytics, we read those data, we parse them to different options and figure out how to use them. Okay? So that's normally how the data processing happens. And I know it's very difficult for you because you haven't done any kind of real-time related activities yet. So visualizing this in the real sense is going to be very difficult for you. But from here, as you guys are already in second year, so it's time for you guys to get started for final year and for the market, because the moment you will pass out, whatever subject you are studying, if will come out, you will get nothing, right? Because market is different. Market wants people to understand real-time tools, real-time skills, real-time job requirements. Whatever you are learning, it's going to give you the basic idea, but the implementation part is something else that you have to focus on, right? So that's pretty much what I would like to cover here. Once you finalize, preparing your data, what to do with that data, it's a different story. You can write your own analytical engine, you can pass it to Google Analytics or some other analytics tool which can generate reports depending on your data type. Okay? we have good amount of 1 hour with us, and we can discuss any kind of topic that you have, any kind of questions you have related to career, related to technology, related to any specific tool, program. Feel free to ask. Like good amount of time with us. I think recording was going on, right? Maybe you can, session is done, so you can stop the recording and you can have a kind of casual discussion about what kind of things you should pursue, how you should get started with your stuff, what are things you would like to learn, how you would like to prepare. You can talk about those. Anything. If you have any questions, feel free to ask.